Okay. Hey, can I grab my cup of coffee here before we keep going? Hey, part two of our energy is we're going to talk about kinetic energy. All right, we're starting with um, the one that is probably most intuitive for us, and this is energy that an object has when it's in motion. So all of our kinetic energy problems are going to be an object that is moving, right? You'll see that in the homework here. All right. It depends on the mass and the velocity of the object. Those are the two factors that weigh into the amount of energy a moving object has, the mass and velocity. And one thing that's interesting is it is not an equal relationship. In our head, we tend to think like, oh yeah, its mass is probably going to be as impactful as its velocity. That's not the case. All right. The heavier, faster objects have a higher kinetic energy. Let me back up a little bit. We know that a car that is driving at 20 miles an hour is going to have more energy than a person that's running at 20 miles an hour. All right. Duh. We're aware of that. However, like I said, um the relationship is not equivalent. All right. So actually your velocity counts for a lot more than your mass. All right. That's why we see some, especially in like contact sports like football, you see sometimes the little guys are able to tackle guys that are a lot bigger than themselves. Some of that's technique, but some of that is that velocity is much more impactful than mass when it comes to the amount of energy. All right, think about projectiles. All right, whether it's a missile or a bullet or those kind of things. They're a very small object, relatively speaking, but they're traveling incredibly fast. And so that bullet that's only a couple grams in size has this massive amount of velocity behind it that creates this big amount of energy. Unit is still in joules. So an object that is 4 kilograms is traveling at 3 meters per second, calculated as kinetic energy. I bet we can do this one in our heads. All right. So kinetic energy equals 1/2 times 4 times 3 squared. We say it again. It's going to equal 1/2 times 4 times 3 squared. So 3 squared is 9, times 4 is 36, times 1/2 is 18. So it would have that object would have a kinetic energy of 18 joules. Do I have it? I don't want to do a bell ringer. Anyway, use that same. I feel like that math's pretty straightforward. So use that same math there for the questions on worksheet number 2, all about kinetic energy. You're going to always square the velocity. Make sure your mass is in kilograms. That's going to be big for one of the questions. And then multiply those by 1/2. All right. Best of luck on kinetic energy.